You built a quantum battery. Good for you. Nicely done. Congratulations. 2022, you got a quantum battery. Hi, this is Ftrhstry. We're recording in a time vortex from the 2120s, and we're looking back at the next 100 years. In 2022, a group of scientists from the United Kingdom and Italy and Australia published a very exciting finding that they have crafted about their work on a quantum battery. And what this quantum battery is basically a system that they're charging with photons, which is cool. You may have heard of solar power technology. This is like that, except it's a battery and it's using some quantum effects. What does that mean? First of all, it's an inert box with dielectric mirrors, and it's filled with organic dye molecules. It's sort of a custom job dye, and they zap this dye with photons and try to trigger an excited state. To the quantum effects at play here are entanglement. These molecules affect each other in their entanglement, which helps them charge faster in like a really cool super absorption pattern, and superposition, which is the dual state of being that a quantum bit can have, of being both excited in this case and not excited. So when you zap it, you're trying to trigger the excited state from the superposition. You're trying to lock it into the excited state, and then you're relying on the entanglement of these molecules to quickly charge the whole system. So what that means is that the charging time can be inversely related to the capacity of the battery. And that's really the most exciting part of quantum batteries. The bigger you get in terms of juice, in terms of number of molecules in the system, the faster it charges. Really cool, very promising. Now, that has limits. It doesn't go on infinitely. There's a certain level at which the density or sheer amount of molecules starts to create different structural behaviors, which affects that charging time. So in the 2020s, that's still an area of open discussion. We've got it a little more figured out in the 2120s, when quantum batteries and quantum processors are quite common in artificial objects. Like, it's actually the standard, more often than not, that an artificial object would have these quantum receptive, energy storing and sharing abilities, and that it would be filled with processing power, which can be accessed and micro-marketed from the cloud. So large organizations are accessing and sort of bidding in these micro-nano auctions for processing time and energy from objects all over the world and in space. That's where this is going. Where it is in the 2020s is this is still quite early days. Not a lot of quantum batteries. It was still theoretical as of just a few years ago, but now you actually have one. It doesn't yet do the fundamental thing a battery does, which is charge something. It can absorb charge, but it can't distribute that charge yet. So scientists are working on that. We'll get to that bit next, and we'll follow up on this in future years as things unfold delightfully. And the other thing it doesn't do very well is retain battery energy, which is, another key battery function. But the sort of tricky bit of the quick charging is that diffusion is also quite quick in these systems. So it gathers the energy from the photons, but then it lets it go. So the scientists have been examining how much charge they got in the system with these very brief, like 10 to the negative 14 second brief pulses of laser energy. And they gauge how much energy has been absorbed in the system by seeing how much of that laser bounces off the molecules in the system, because once the molecules are excited, they will no longer absorb the photonic energy, and they will bounce it off, and they can get a read of how much they've charged the battery. So they've got that much going. And that's really good research, and it's a platform for stuff that will be quite important in days ahead. They will be figuring out how big they can make them without this super absorption effect getting wonky, and they will figure out how to transfer that energy out to other objects, and they will figure out how to increase the storage time. The one thing they've got on that so far is if they blast the system with just the right amount of noise, they can trigger a sort of dark mode, which locks in the energy and slows down the diffusion. So check these things out. There's a university in Milan in Australia and in the UK. There are like 3 in the UK, St Andrews. We'll put them in the commenty place, and maybe you can comment on them. Or tell us if you've invented your own quantum battery in your quantum garage. We hope you're feeling charged up for the future. You have the power to do the things you want. Future bye!